In 1970, scientists in the Soviet Union set out to drill the deepest hole in the world. They weren't drilling for oil or gas, they were just drilling for the sake of drilling to see what they could find. And they actually found quite a lot. Learn about the Kola Superdeep Borehole, the deepest hole on planet Earth, on this episode of Everything Everywhere Daily.
Do you really know how the internet works?
Can you even explain what communism actually is?
Have you ever asked yourself, how did I not know that?
I'm Jack.
And I'm Nat.
And we're the hosts of How Did We Not Know That, a podcast that covers all the things that you should know, but don't.
Listen as we have unscripted conversations about child labor, secret wars, and stock market crashes.
Find How Did We Not Know That wherever you listen to podcasts.
Before we dive down the hole on this topic, pun fully intended, we should do a brief review of how the Earth is structured. At the top, the part we live on, is called the crust. The crust is actually quite thin in the big scheme of things. The crust makes up less than 1% of the volume of the Earth, and it's only about 5 to 70 kilometers deep depending on where you are on the planet. The crust is thinner on the oceans and much thicker on land, especially under mountain ranges. Below that is the mantle, which makes up the vast majority of the volume of the Earth. And finally, in the middle is the Earth's core. The boundary between the crust and the mantle is called the Mohorovicic discontinuity, or the MOHO layer. Scientists wanted to get an actual piece of that part of the Earth. We've sent space probes out 10 billion miles, but we haven't really gotten a glimpse of what's sitting just a few kilometers below our feet. In the 50s and 60s, the US and the Soviet Union engaged in a very unsexy and not well-known competition to drill the deepest hole and try to be the first to reach the Earth's MOHO layer. The United States started in 1957 with Project Molehole. This was a drilling ship anchored off the coast of Mexico which tried to drill through the crust at one of its thinnest points. They began drilling in 1961 and managed to drill a whopping 183 meters below the surface of the seafloor. If that doesn't sound like much, you need to realize that they were drilling in waters 3,600 meters deep. As a scientific project, it failed in its attempt to reach the mantle. As an engineering project, it was actually a great success, and the techniques they learned became the basis of offshore drilling platforms. The Soviets began their project in 1970 up on the Kola Peninsula, only a few kilometers from the Norwegian border. Drilling can take a long time, and it especially took a long time here as they were drilling through solid granite. In 1972, an oil well known as Bertha Rogers was drilled in Oklahoma, which in 2 years set a drilling record down to 31,440 feet, or 9,583 meters. They eventually had to stop because the heat at that level prevented further drilling. The Oklahomans basically started later than the Soviets and lapped them in just 2 years. But they were drilling in far easier earth. The Soviets also weren't just drilling. They would stop frequently to analyze the samples they were bringing to the surface. The Soviets just kept on drilling. By 1989, they had reached their maximum depth of 12,262 meters, or 40,230 feet. That's deeper than Mount Everest is high, and deeper than the Marianas Trench. There are actually several holes that branch off the main hole, which is also why it took so long to drill. The main hole is only 9 inches wide, or 23 centimeters wide. So, after 20 years of drilling, what did they find? Well, actually quite a lot. For starters, there is a lot more water than they expected. Geologists didn't expect to find any water that far down. The compression of the rock is so great that they didn't think there would be any room and it would be pushed to the surface over time. They found a lot of water. In fact, many geologists now think that there is as much water below the seafloor as there is above it. Granted, it's all tied up in the rock and it's spread out over a much larger depth than the oceans, but it's still a lot of water. Next, they found a lot of gases that they didn't expect. First, they found helium. That was expected. Helium is the natural byproduct of naturally occurring radioactive decay. When uranium or thorium decays, which can take billions of years, it expels a helium atom that doesn't chemically bind with anything. They also found hydrogen. You almost never find hydrogen in its raw form on Earth. If it's in a gaseous form, it'll rise out of the atmosphere and escape. They also found carbon dioxide. The source of carbon dioxide might have something to do with one of the other things they found: fossils. 6 kilometers, or 4 miles below the surface, They found 24 different species of microscopic plankton fossils. This is something that confirms observations made around the world that there is a staggering amount of microbial and microscopic life below the surface of the Earth. These small life forms have astonishingly slow metabolic rates and long lives. From a geologic perspective, the biggest discovery was the lack of basalt. Basalt is the type of rock you tend to find on the seafloor. Seismic readings detected a layer below the granite, which is why they expected it. It turned out that the heat and pressure metamorphized the granite into a different form, and that's what they observed. Finally, the temperatures were much higher than they expected. The temperature was 356 degrees Fahrenheit, or 180 degrees Celsius when the drilling ended, whereas they only expected 212 degrees Fahrenheit, or 100 degrees Celsius. In the early 90s, the Kola Superdeep Borehole project ended due to a lack of funding when the Soviet Union fell apart. Today, the drilling facility is a ruin, and the hole itself is just covered with an iron cap. The building is literally falling apart with massive holes in the wall and the roof. In the process of drilling, the Soviets had to invent new techniques to deal with such extreme depths. One of the biggest ones was how to rotate the drill bit over such long distances. Normally, the drill bit is at the end of a very long shaft and the shaft is rotated. However, when the shaft is several kilometers long, it becomes impossible to rotate to get enough torque to actually eat through rock. They developed a new type of bit which rotates when high-pressure fluid is pumped down the hole, eliminating the need to rotate the entire shaft. This technique is now used all over the world on drill rigs. Since the end of the project, there have been other deep boreholes attempted, but nothing has been as deep as the Kola borehole. In Qatar, there was a well dug which was just a hair longer, but it wasn't deep because it went horizontal. In Germany, there was a hole bored down to over 9,000 meters, but there they encountered temperatures twice as hot as what was discovered in Russia. In the future, it's entirely possible that we might create a hole that's deeper, but probably not much deeper. The temperatures, once you reach a certain level, make it next to impossible to drill. Thankfully, with what we've learned from deep boring projects in the past, if someone should try to break the record in the future, they should at least know the difference between their head and a hole in the ground. The executive producer of Everything Everywhere Daily is James Makkyla. Today's first listener review comes from Leif Peterson over on Stitcher. He writes, "Fascinating, bite-sized, interesting, fascinating morsels of information." Over on Apple Podcasts, Todd T91 wrote, "Excellent, well-researched, excellent short-form podcast." Well, thank you very much, Leif and Todd T. And remember, if you leave a review over on Stitcher or Apple Podcasts, you can have your review read on the show.